Hello, my wonderful computer science students. Welcome to another lesson in Unit 1, using objects and methods. Today we are going to be going over Lesson 3, which is going to be expressions and output. Now, our objectives for today, we are going to be looking a little bit more at expressions and really what our output looks like. We're going to be looking at input. We've already seen assignment statements in Lesson 2, but we'll be dealing a bit more with assignment statements as well as how to get user input for the first time. And then we're going to be talking about not only the operators in general and the order of operations in Java, but also compound assignment operators, which are a special type of operator in our programming languages. So we have a lot to cover today. Let's go ahead and jump on in. My name is Goldie if you're new here, and I'm ready to take you through this lesson together. Let's first talk about printing to the screen. So we've already seen how we print to the console. And in our IDE, the console represents what gets printed to the screen as we run our program. So our program that we're going to see and that we have seen before uses what's called System.out.print and System.out.println. Okay, so you see here we have two what are method calls to print to the screen. So we'll use print, which is open close parenthesis, and we'll use print, and that's an ln, open close parenthesis. And they both print to the console, but they do so in different ways. With just the print, it prints to the console, but then it waits at the end of the line. So think of like a cursor on the computer screen, right? When you're typing, you see that cursor as it moves. When you do the print statement, it's going to print and then leave the cursor at the end of whatever it prints. Versus print line or print ln prints to the console, and then after it's done printing, it's going to move that cursor to the next line. So both of them print to the console, but do so in different ways. So we've seen our Hello World program. Let's see a different type of program with just print statements. So we have our public class welcome, our main method, and then the first line that is going to run is going to be the System.out.print line. Okay, so it says print ln, print line, and it's going to print welcome to our class. So what happens here, it's highlighted here, what prints on the screen in the console is welcome to our class. And then you see that cursor there, that vertical purple line that I have, it moves it to the next line. Okay, so that string literal, what's between quotes, not the quotes themselves. The quotes themselves don't get printed, but it's what's between those quotes, that string literal gets printed, and then the cursor moves to the next line. For this next line, we have System.out.print 5. And when you just have a number without any quotes around it, it's just going to print that number. So it's just going to print 5. And notice where the cursor is at now. Because it's just a print statement, the number gets printed and the cursor waits at the end of the line. Okay? So that when we come down here to do our next statement, again, what's between the quotes, between the string literal is printed. So the equal sign is printed. And then because, again, it's just the print, the cursor is still waiting at the end of that line. Okay. So we've had 3 lines printed. We had welcome to our class, and that moved to the next line. Print a 5 and stay, print an equal sign and stay. So we've had 3 lines of code. This last line of code, we have 2 plus 3. In here. So what do you think is going to happen there? Because there's no quotes around it. It's not a string literal. What's going to happen, the expression, since it's not on quotations, it's going to evaluate the math first and then print the result, which is why the last thing printed here is a 5. Okay? And then notice where the cursor is at. Because this was a print ln, the cursor moved to the next line. And then the main method is done. The class, everything is done. Well, the main method is done. So the program's done when the main method is done. Everything is done. So the console looks like this off to the right here. So that's going to be our output. Those are the 2 ways we're going to output to the screen. There are definitely a lot of different ways we could output, right? There's a lot of different methods for output, not only text output, there's audio, there's different visual outputs. In AP Computer Science A, we are only dealing with text output. And both of these, println, and print, are going to be on the AP exam. So these are the only two ways you are going to output anything. So you're going to want to make sure you know them. The next thing we are going to cover is our input. Okay. So in our input, we can have different types of input, for input from the keyboard, from the microphone, from the camera, whatever it is. We are going to talk about how we use the scanner class to get that input. So what we've used before, we use System.out, and that refers to the output device. And System.in refers to the input device. You see how that works? Now, this system class itself, the system class is part of the java.lang package, which means that we don't have to import it or have an import statement. It's automatically imported in our program, which is why we were able to use this System.out without using any extra code, right? We just used it, okay? Because the code for it to actually get the text to the screen has already been written for us, okay? And it's going to be the same thing with the System.in that we're going to use. You can just use System.in in your program when you need it, and you don't actually have to import anything. By default, the output device is going to be display monitor and the input device is the keyboard. Okay, so when we just use them as is, the System.out prints to the console and the System.in is going to take input from the keyboard. And to get the input from the keyboard, we actually have to use another class called the scanner class. The scanner class is going to create an object to read input from the System.in. Okay. Ooh, there's a lot of interesting things in that statement there. A lot of assumptions being made. This is going to be the first class we're going to see. Okay, and the first class we're going to use. We'll talk more about classes in the upcoming lessons, but this is going to give you your first taste of using a class to create an object. Now, I don't want you to worry. I'm going to give you the code for this, and you just got to memorize this code because you're going to use it so often to get user input. It's going to become second nature. So right now, when I start to show you this code and show you the steps for getting user input, I just want you to memorize it, okay? We'll learn all about the schematics of it, why it works, how it's useful. All of that comes later on when we talk about objects and object-oriented programming. For right now, just say, okay, Goldie told me I got to remember this, so I'm just going to remember it, and this is how I get user input, okay? There's going to be 3 steps we're going to use to get user input. To display to the screen, we just use System.out, and it was beautiful. We just displayed it, right? But to get input, we actually have 3 steps in our code that we have to do, okay? And you're just going to memorize these, okay? We'll learn about the why later, just memorize these. First, we're going to import the scanner class. Then we're going to create a scanner object, and then we're going to code the user input, okay? Which I know sounds like a lot, but we're going to memorize these 3 steps. And like I said, you're going to use them so much in this class, it's going to become second nature, okay? So first, when we talk about importing the scanner class is in a different package than the system class. The system class we could just use, it's just automatically imported and used in our Java programs. The scanner class is not. It's part of what's called the util package. So we have to import java.util package in order to use it, okay? So the import statement tells the compiler where to locate the classes, what package to locate the classes in, and then the compiler is able to pull from that package, pull that class, and that class, the scanner class, has already been written for us. Someone else created this code that we're about to use. So instead of recreating this code, we're just going to pull it from its package. Like think of picking a book off of a shelf, right? You pick the book off the shelf and you read the book. You didn't have to write the book, right? You can just read the book and use the book however you want to use the book. That's what's happening with this scanner class. We're going to take that scanner class, we're going to pick it out of the package, and we're just going to use it. Okay, and we're going to use it to get user input. Now, how it gets user input, we're not interested. We're just using it right now. We're not going to understand the how. We're just going to use it. Okay. We're using that code that's already been written, importing those classes. So to import the scanner class, this is the code I want you to have memorized. Okay, import java.util.scanner. Okay, so that's UTIL. You're going to put that at the very top of your program, even before your public class main or public class example, whatever you have as your class. You're going to put that right above it. It's a statement, so you're going to end it with that semicolon, and that's importing the scanner class. That is the one line of code that you put in to import the scanner class. Okay, so that's step one. Step two is to create the scanner object. Okay? And again, this is code you just memorized for creating a scanner object. We have not talked about objects yet, but we will. Okay? So just memorize this. Scanner, keyboard, equals new scanner, and then in quotes, system.in. Goldie, how on earth am I supposed to memorize that? Don't worry, you'll be all good, okay? Memorize this code. This is going to actually go in our main method. Okay? So that import statement went above our class. This line of code is going to go in our main method. So we're using scanner. We're saying, hey, we're going to make a scanner object. So say scanner, okay? And then keyboard. Keyboard is an identifier. We talked about identifiers in lesson 2. Keyboard is an identifier, letting us be able to use it to get user input throughout our program. I chose keyboard, and I always use keyboard as my identifier for my input device. You can use any word here. It's an identifier. So remember, identifiers, you could call this X and it would be fine. But usually we want to put a purpose behind the identifiers. You see what I'm saying? So I use keyboard. Other common identifiers, people use scan. Some people just use KB or reader. Okay, these are just the common ones kind of used in practice, but I always use keyboard. Okay, so you'll always see me use keyboard. Equals new. New is part of creating an object. Scanner, we're going to repeat the class that we are using. And then in parentheses, we're going to use that system.in because this tells us we're going to look for keyboard input. Okay. System.in, the default for system.in is keyboard. So this tells us where to look for our input. Scanner says, okay, I'm going to scan for some input. Where am I scanning? Again, we could use input. I'm using input right now for a microphone, right? But in our program, scanner's like, okay, I'm scanning for something. What am I looking for? System.in says you're going to use the keyboard because the default for system.in is keyboard. We'll talk about other ways to get input later on in the course. Right now, keyboard only, okay? So I use the word keyboard or any identifier you make it, and I use keyboard in my class anytime I want to get user input. Maybe I just want to get user input once. Maybe I want to get it many times in my program. But anytime I want to get user input, I'm now going to use keyboard. Okay. You can use it, again, as many times as you need, once or hundreds of times. But once I create my one scanner object, that is all I need to do. Okay. You only need to create the scanner object once. Just like you only need one import statement, one create the scanner object. Okay, step 2. Step 3, the final step, is actually to code the user input, okay? How do I actually get the user to input, okay? First, we declare a variable that will hold the user inputted value. So if I put in a number, right, I need a variable, a container to hold that number, to hold that data. So I'm going to declare the variable, and then I'm going to get the user input. So what that looks like, again, this is the memorization part. Int value equals keyboard.nextInt. Okay, so keyboard, that is my identifier that I always use. And then .nextInt, that's going to be the method that says, hey, you're going to look for an integer being put into the keyboard. The user is going to input that integer, and you are going to store it in the container called value. Okay. So in our program, what will happen is value will be created, and then the program waits for user input. So the program pauses, and you'll see it just wait for your user input. Okay, and then once the user inputs an integer, then it's going to store it in value, and the program is going to continue. Okay, So it waits for the next integer, and then you do have to press enter, and then the number is then stored in value, okay, as the user will do. Okay, so those are our three steps. So let's put it all together in a program and check this out. Okay. Here's my program. Okay, so the very first statement, you notice I have my import, java.util.scanner. Okay, so that goes first. That goes above my class here. Import java.util.scanner. Oops. Sorry, I got a little ahead of myself. So then I have my public class main, public static void main, right? So I have my main class, my main method, and then the very first line inside my main method is to create my scanner object. Again, it's just what I said before. I'm making it right now. Then what will happen, I have a print statement that says enter your age. So to the console, it's going to print enter your age. And because it's a print statement, my cursor is going to wait right there after my colon. Okay. And why is it going to wait? Well, it's going to wait there. Okay. Notice how it doesn't move on to line 7. It doesn't automatically print this. Why? Because it's waiting on line 6. On line 6, we are waiting because we have a next int. The console's waiting for your input. It created the age variable, and then it's waiting right here because of this code. It's waiting for you to input a number. Okay, so you'll input a number if your age is 17. This is what the user typed in. 17 gets stored in age. So when I come down here to line 7 and I say your age is, in quotes, and then I have this plus symbol, age, okay, that's saying print your age is, and there's a space right here, so there's a space right here, and then put in what's stored in age. Okay, what's stored in age? Well, you put in 17, we stored it in age, so then 17 gets printed off. It's concatenated, that word, we've said that word before in lesson 2, concatenated with the age you just entered. So the screen puts the string literal together with this integer, okay, and prints it to the screen. Okay, so the word age doesn't get printed. If you had quotes around here, then the word age gets printed. But no, because there's no quotes, it's not a string literal, it is a variable in your program. So when you put a variable in your program into a method, it actually uses the value there. Okay. A lot going on. Okay. As you work on, I don't expect you to have this memorized at this moment. So as you work through your problems and practice assignments, go back to this code segment, see how it's correctly written, model that in your program, and then you'll start the process of being able to memorize this. Okay. So this is the code to get an integer. Okay. What if you want to get other things from the user? Like what if you want a decimal or a word from the user? Okay. We have other ways to ask for that. It goes with the same code, but instead of next int, you're going to do something else. For example, if you just do keyboard.next, keyboard.next is where you get everything the user types. So the user could type a number, it could type, they could type a word, they could type a sentence. If you want to get anything, you would use next, okay? Or excuse me, sorry, just next is the next token, okay, which is a white space, or enter by default. So this would be if you want to get a word, okay? This would be if you want to get a word, .next, and it gets stored in a variable that is a string. So string example equals keyboard.next. So it gets next. So if you enter a 5 and then a space, it would get stored into example. If you enter the word 5, it would get stored into example as a string. Okay, anything you enter up until, again, a white space, a space, or enter by default, white space being like a tab, it will be stored in example. Next line, okay, that's where you can get a sentence put in, okay, or whatever you want. If you want to include the user entering spaces and other things in there, you would use next line. Okay, so this will get anything. So if I say 5 space 5 space 5, I could keep typing forever and it'll capture anything I type up until the enter key and store that in example 2. The other one that you'll probably use would be next double. So this is if you're looking for an integer a decimal from the user. They would enter a decimal and it would get stored in example 3. Okay. Now, if your user inputs a value that does not match what the code was expecting. So if the code was expecting an integer, let's say, you had to enter an integer, but the user, instead of typing the number 5, they typed the word 5 or something and pressed enter. You're going to get a runtime error. The error is called an input mismatch exception. It's a runtime error and your program will crash. Now, there's ways to handle your user entering values that you are not expecting. That in user input in general isn't covered on the AP exam, and we're going to learn a few different ways of how to handle user input as we learn more code. So I don't want you to get hung up on what happens if the user enters something incorrectly at this moment. For right now, in the programs we're going to write in class and in the next couple lessons, we are going to assume that the user is smart and they're actually going to do what we tell them to do. Okay, but we can't always assume that. So I'm going to talk about how to code those situations later on. Okay, but just know if something does happen and you get an exception, input mismatch exception, that's what happened. Okay, so just know. All right, that's it for user input. Okay, so now we're moving on to the next part of our lesson, which is talking about expressions, both mathematical expressions and expressions involving strings as well. So first, let's talk about math expressions. Let's talk about the order of operations that we know and love from math class. It's basically going to be the same with just some minor differences. The order of operations for Java, it always starts with parentheses first. Okay. In Java, as you've seen, we have special symbols like the square brackets and the curly brackets. Those do not come into play when it comes to the order of operations, right? Sometimes in algebra, you could use special brackets to like group. You never use those special grouping symbols when you're making a math expression in Java. You can only use parentheses as a grouping symbol. Okay. You can use as many parentheses as you need or as many nested ones as you need, but you can only use parentheses. Order of operations next, we go to multiplication, division, and modulus. Now, if you don't know what modulus is, we are going to learn about this, okay, in this lesson, so stick around. But it's a new type of operator, but we do multiplication, division, modulus. All of them are on the same line. We do them in order from left to right, okay? After we do all of those, then the last thing is addition and subtraction, left to right again, okay? There's no built-in exponent symbol, okay? So like sometimes you'll use the caret, like on your calculator, when you're typing and stuff. That is not the case for Java programming language. There's no caret symbol. Okay, so exponents, we have a different way of dealing with it. We're going to talk about later, but there's no built-in exponent symbol. What you're looking at on the screen, those are the only built-in symbols that we have. Parentheses, the multiplication is an asterisk, and the division is going to be the slash, and then the modulus is going to be the percent symbol, and then the addition and subtraction symbol. Okay, so let's look at expressions. So this is just basic math expressions. These expressions might be stored in a variable, or as you see on the screen right now, they might be evaluated and printed to the console. So if I have 3 plus 4 times 2, okay, so that asterisk, again, that asterisk is multiplication in Java. What is going to happen? Order of operations says that we do the multiplication first, and 4 times 2 is 8. And then 3 plus 8 is evaluated and becomes 11. Okay, so what gets printed to the console? 11 will get printed because it evaluates the math expression and then it displays it to the screen. Okay, so math expressions might get evaluated right inside your print statements. What also might happen is you have a math expression that's going to get stored into a variable that then gets displayed to the screen. Okay. So you can see we have our math expression over here. Whatever this expression evaluates, and that answer gets stored in the variable answer. Okay. So remember that that equal sign is an assignment statement. So we don't do like algebra in the typical like add on both sides, subtract on both sides kind of way. It is assignment, and assignment always happens last. So we use the order of operations on the right side, which says if we have addition, division, and multiplication, division and multiplication are on the same order precedent, but we do it in order from left to right. So because we hit the division first, we do the division first. So 5 divided by 5 is 1. Okay. Now that we have 1, we're left with addition and multiplication, and we do the multiplication next in order of operations. So we do 1 times 2, which is 2. And then the last thing we do, we just have 2 plus 2. 2 plus 2 is 4. So that means 4 gets stored in answer, and then we print off 4 to the screen. Here's another way you might see it, expressions. I have an x, y, and a z. And variables in this situation are used in expressions like numbers. So I have 9 being stored in x. I have 2 being stored in y. So this is sometimes what I do to help organize what is being stored in my variables. So I'll say, okay, x gets a 9, y gets a 2. And those are my first 2 lines of code right here. 9 gets stored in x, 2 gets stored in y. And then what gets stored in z? Well, it's this expression. Okay? But it's not just that expression. Okay, z needs to be an integer. Okay, z needs to be an integer. So there has to be an actual value that is stored in z. So what does Java do? Java uses those x's and y's and uses the values currently in those x's and y's to evaluate the expression. Okay, so z gets 2 plus 9 times 9 because the value of y is currently 2 plus 9 times 9. Okay, it evaluates this, so you have to figure out a value. It's not just this expression gets stored in z. You evaluate it. 9 times 9 is 81. 2 plus 81 is 83. So it's 83 that gets stored in z. So when I go to print out what z is, I'm going to print an 83. Okay. All right. Now let's talk a little bit more about some of the nuances around these expressions here. So if I take 9 divided by 2, if you were to put that in your calculator right now, you would get 4.5, right? 4.5. But in Java, when you have 2 integers and you are dividing them, what is the result? It's what's called integer division. So integer division, which is division between 2 integers, it only takes the whole number as the answer. So 9 divided by 2, because they are both integers, Java performs integer division. So the answer isn't 4.5. The answer is to the question, how many times does 2 fit into 9 evenly? Okay, and that's really what integer division is. How many times does 2 fit into 9 evenly? 4 times. Okay, so what gets printed to the console is actually a 4. Okay, and that's going to take some getting used to because that's not really what you expect, okay, when you think about 9 divided by 2. But between 2 integers, we perform integer division. What if we start mixing some types? Okay, so before we get into mixing types and mixing integers and doubles, let's look at one more example here. I have an int x equals 9, int y equals 2, and then I have 9 divided by 2, but that's going to be stored in a double variable. Okay. So what happens? Well, 9 is an integer, x is an integer, and y is an integer. And what Java does is it always evaluates this first. So it doesn't even look at storing it in Z yet, right? Even if the container is sitting there created and declared, it doesn't look at what Z is. Right now, it's just focused on evaluating this expression. And in this expression, 9 is an integer and 2 is an integer. So what's going to happen? It's going to perform integer division. Okay, so 9 divided by 2 is going to be 4. Okay, because those are both integers, the expression is evaluated as an integer division and the result is stored in the double. So this is going to be 4 as an integer, but it gets stored in a double. And remember, that's okay. We can take an integer and store it in a double because an integer is smaller than a double. Okay, so we can take a 4, we can put it in a double container, and that's fine. What's different is when I go to print off this double, 4 is the integer stored. What gets printed off is actually 4.0, okay? Because when integers get stored as doubles, they get that 0.0 attached to them, okay? So if you start seeing, when you start printing off doubles, and you know there's an integer in there, an integer value, what'll actually get printed to the console has that 0.0 after it, okay? So just be aware of that. That's signaling that, hey, even though 4 is an integer, it is stored as a double, and it is treated as a double there. Which brings us to this idea of mixed expressions. A mixed expression is an expression that has operands with different data types. So when we start mixing ints and doubles. So we said before that double hold larger spaces in memory. So it has a bigger container. Double is considered more complex, essentially. And whenever there's a mixed expression between ints and doubles, Java will temporarily promote the less complex type so that it matches the more complex type, and then the operator is applied, okay? Because remember, an integer can fit into a double, but a double cannot fit into an integer. So let's look at the situations where this is going to come up, okay? So I have 4 different code segments here with 4 different results, okay? And I have some reasons about why. So let's look at 10 divided by 4, okay? So this first one is 10 divided by 4. 10 and 4 are both integers. How do I know that? Because there's no decimal component after it, okay? If you glance ahead to the next one, that would be your decimal component if you add the 0.0. But 10 and 4 right now are integers. So it's integer division, so the result is an integer. How many times does 4 go into 10 evenly? 4 goes into 10 twice, right? 4 and then 8. It only fits in twice. So the console will print off 2 if you do 10 divided by 4, integer division. Okay. Now when you look here, we have 10.0 and 4.0. So those are going to be 2 doubles. When you perform division between 2 doubles, you get division as expected, okay? The result will be a double. So 10.0 divided by 4.0 will be 2.5. An expected result, like when you're working with your calculator, right? 2.5. Now, what happens when you mix? Because right now we have an integer and we have a double. Okay? So this is what we were talking about in the last slide when we said the less complex will get promoted temporarily. So what that means is when Java sees we have an int and a double, Java will say, hey, integer, you're going to be promoted. You're actually going to be promoted temporarily to a 10.0, and double division is going to apply. Okay? Mixed expressions. So the answer is 2.5, the same as this right above it, because the 10 got promoted to a double. Okay? And it got promoted to a double because it was in an expression with a double. Okay? All right. And I say temporarily promoted, like in this example, this last example here. A is 10. Okay? A is 10, B is a double. So right here, if I do A divided by B, A is 10 and B is 4.0. Okay, so it's the same situation we just had here. Okay, where I said, okay, the 10 is going to get temporarily promoted and double division is going to be performed. So this becomes 2.5, which is going to get stored in C, which is good because C is a double. Okay, I was expecting that. Okay, so when I go to print off, C, I print off 2.5. When I go to print off A, what is the value of A? A is still 10. Okay, A is still an integer. It is not 10.0. Okay, in this expression, it got a temporary promotion, okay, in order to perform the double division, okay, or the regular division. But it did not get promoted permanently. A is still 10, okay? So keep that in mind as you're working with your code, okay? That is important. All right, we're working through, I know this is a long section of notes, but we are getting towards the end. You are learning so much, and I'm so happy you're sticking with me, okay? Let's look at a few more pieces of code. Now we're gonna mix some other expressions here, okay? Including strings. So let's look at this next segment of code. I have a 1.0 times 3 divided by 4, okay? How does this get evaluated? I have multiplication and division. Order of operations says they have the same precedent, so it's going to get evaluated from left to right, okay? So that 1.0 times 3 is evaluated first. It's a mixed expression because the 1.0 is a double, the 3 is an integer. So the 3 gets promoted to a 3.0, and I have multiplication performed. This becomes 3.0. So now I have 3.0 divided by 4. And again, I have a double and an int. So the 4 gets promoted to a double. So I have 3.0 divided by 4.0. And when you have like regular division like that between two doubles, or the promoted double and the actual double, you're going to have division like you would expect. So what's 3 divided by 4 regularly? It's 0.75. Okay? So this is going to print off 0.75. Okay. Be careful, because if you didn't understand the order of operations, you might do 3 divided by 4 first, which if that's integer division, that would be 0, okay? Because 4 doesn't go into 3 evenly at all. That would be 0, and then you'd have 0 times 1.0. And then you're like, shouldn't the answer be 0? No. It's not 0. Order of operations, okay? It matters. Okay, next we have a string literal. What do we call a string literal? Whenever we have these quotes, right, what gets printed is exactly what's between here. So even though this is a math expression, 3 plus 4 literally will get printed to the screen because it is a string literal. I say literally. Literally gets printed to the screen. Okay. We talked about mixing strings and integers in the last lesson. If I have a string literal plus an integer, okay, what'll happen is it's a mixed expression where the 4 is promoted to a string. Because it's a mixed expression, string is more complex, okay? So 4 gets promoted to a string. So what gets printed to the screen is a 34, okay? It basically treats the whole thing like a string itself and will print off exactly as it sees. Okay. Last two code segments here. More mixed types. What happens when you have 3 plus 4 plus 5, okay? When you're mixing all of those together, okay? Well, what happens is the way Java allocates memory, it recognizes that this is a string, and what's going to happen is it's going to see the rest of this expression as a string. So it's going to say, hey, I'm going to print 3 to the screen. Oh, here's a 4. I'm going to print 4 to the screen. Oh, here's a 5. I'm going to print 5 to the screen. So what gets printed to the screen is a 3, 4, 5. Okay. Once it starts working with strings, it continues working with strings. Okay. Continues working with strings. If the opposite was true here, okay, it would start working with operations and it would actually print a 9. And then the 9 would get pushed together with a 3. So you'd get 93 printed. Okay. So that's important. Know the difference. Play around in your IDE if you want to practice that a little bit to try to predict what gets printed. Okay. What you can also do if you wanted 39 to get printed is you can use the order of operations. Okay. Because even though Java starts on the left and works to the right, order of operations takes precedent. So if it sees those grouping symbols in here, like right here, it's going to do those first. So it's actually going to say, oh, I have 2 integers, a 4 and a 5. I'm going to add those together to get a 9, and then I'm going to work from left to right. So then I'm going to print the 3 and a 9. So this is going to print 39. When in doubt, or when you want a specific type of output put your parentheses, okay? If you're mixing expressions like this. Okay. Let's talk about a few things here. First is an arithmetic exception. So this is a common one that happens when you divide by 0. You, as great math students, know, do not divide by 0, right? If you divide by 0 in your code will actually compile correctly. The compiler doesn't catch that as a syntax error. But what will happen is it'll have a runtime error. Okay? And when you have a runtime error, this is a specific type of runtime error called an exception, and an arithmetic exception will be thrown. So for instance, the code you see, the 3 lines, will compile fine. It's totally legal syntax, nothing's wrong with it, and the compiler will say, yeah, that's totally fine. But when you go to run it, your program will crash. Okay? Try it if you don't believe me. See how your program crashes, okay? It's good to get familiar with a crashing program anyway. Depending on your IDE, some IDEs handle a crash program okay. Some IDEs don't handle a crash program okay. So see what your IDE does, okay? But yes, we're dividing by 0 here because we're taking 5 divided by 0, which is not allowed, and your program will crash, okay? This might be what it looks like. Most IDEs have ways of handling something like this. So take a note of it. It'll tell you what line it's on as well, usually. So you can actually identify where the error is occurring. Okay. All right. We're going to talk about 3 last things: compound operators, unary operators, and modular division. Okay, so I know we're pushing the boundaries of a video here, so I appreciate you guys, again, sticking with me and learning about this. Let's talk about compound operators. Beyond those arithmetic operations that we just saw, compound operators that we use in programming help us just write more simpler code. Simpler code? Okay. So here is like a regular operation, x equals x plus 5. What this says is take the value that x currently is, add 5 to it, and then store it back in x, right? So if x was 65, then I would add 5 to it and store it back in x, okay? A compound operator simplifies that expression. And instead of writing it as the regular operation, we write it compound. X plus equals 5. So it says take x, add 5 to it, and then store it back in x. Okay? It's a shorthand way of writing this. Okay. We have one for subtraction, minus equals. For multiplication, times equals. Division, divide equals. Mod, when we talk about mod here in a few moments, mod equals. And then we also have special cases where we have +1 and -1. Okay, these are going to be called unary operators. When we just want to add 1 to the value or subtract 1 from a value, we can make it even more shorthand. Okay, we could do a compound operator of x plus equals 1, but there's an even shorter way to do that, and it's x plus plus. Okay, or we could do x minus equals 1. Or we could do x minus minus, okay? So these compound operators are just shorthand ways of writing these regular operations, okay? Do you have to use compound operators? No, you could get through your entire Java career without ever using a compound operation, but it makes code easier, especially when you start getting long programs, okay? And we're gonna be using them throughout this course very regularly, so you're gonna wanna be familiar with them. So here's a quick practice. If you want to pause the video, try it, and then come back. It's just getting familiar with them. Simple operations, but I want you to get familiar with visually how these compound operators look, okay? Press play again when you're ready to see the results. But x, the value of x is 10. We add 5 to it, so x is 15. Y is 17. We subtract 4 from it. Y is now 13. Z is 9. We times it by 5. Z is now 45. Okay. All right. Now, a little bit more about these unary operators. So how you'll normally see them is what's called the post increment and post decrement way. So this way and this way is how you'll see them on the AP exam. And that's almost always how we use them in our program. Okay, what you're going to see when we get to eventually loops and all of that good stuff, we use the post decrement and post increment. But I want to just point out you can have pre-increment and pre-decrement. What actually happens is the same thing you would expect to happen. Okay, if G is 5 plus G is now 6. If I is 5 post increment, I plus I is 6. For all intents and purposes, pre-increment and post-increment do the same thing. Same thing with pre-decrement and post-decrement, right? If you have 0 as H and you subtract 1 from H, you get -1. 0 as P, subtract 1 from P, you get -1, okay? For code like we are using above, it does not matter if you use pre or post version, okay? It does matter when they are parameters. Okay, like for instance, the parameter we use is the println method. Now we haven't really formally introduced what the word parameter means, so don't worry too much about that yet. I'll give you an example of where it matters in the next slide about pre-increment and post-increment. Okay, but just know that we're now getting into something that is not covered on the AP exam. Like I said, the AP exam just uses the post compound assignment for this. It doesn't do the pre. Okay, so you don't actually have to know the differences in this example, but I want to point it out just in case you are working with your code and something funky happens and you're like, why did that funky thing happen with my code? This is why. Okay, so what's printed? Let's say we have double example equals 4.5. Okay, so example has 4.5 and I want to print plus example. So this is an operator. So what it does is it adds 1 to 4.5 and then changes. So example, if I were to trace it, example has 4.5 in it. Okay. Used as a pre-increment means, hey, you're going to add 1 to it before you do anything with it. Okay. So that means you're going to add 1 to it and then you're going to print it off. So the output is 5.5. So example is currently 5.5. Example is currently 5.5. It was 4.5. We got rid of that. It became 5.5. And 5.5 printed off. Now when we get to this line, example plus, okay, example plus, because it's a post increment, what a post increment does inside of a method like this, it says, hey, display what's currently in example. And after you do that, then add 1 to it. So what'll get printed off on this line is actually 5.5, and then example will have 1 added to it. Okay, so it was 4.5, it was 5.5. So this line of code said, hey, print it off and then add 1 to it. So then it became 6.5. So we printed off what it was, 5.5, and then added 1 to it. And then now when we come down here and print it off, what is example currently? Well, it's currently 6.5. So 6.5 is what's going to get printed off to the screen. Whew. Oh my gosh. Goldie, are we done yet? We are so close to being done, y'all. Okay, we're so close. We have one last thing-ish to talk about, and that's modular division. Okay, so modular division, if you haven't seen it yet, it's basically the remainder operator. Okay, so when we divide one integer by another, like 7 divided by 2, we would expect 3.5, right? But we just talked about integer division. If I took 7 divided by 2 as integer division, I would say it's 3 would be my answer. What it fully is it's 3 remainder 1, right? 3 remainder 1. So modular division is finding that remainder after that integer division is performed. So 7 divided by 2 as an integer division would give us 3. 7 mod 2 is going to give us the remainder 1. Okay. The remainder operator is the percent symbol. It's also called the modulus operator because this is modular division. The mod operator has the same precedence as multiplication and division, so it's treated the same. It just asks a different question, right? So before integer division said, okay, how many times does 2 go into 7 evenly? It goes in evenly 3 times. If I said, okay, what's 7 mod 2? That's asking what the remainder is. So that answer would be 1. Okay. So on the AP exam, it's going to be simple operations. You're not looking at huge numbers that you have to do this with, okay? Maybe you'll write a program using huge numbers, but when we're just talking about, hey, what's 10 mod 6? That's going to be the type you might have to do on the AP exam. So what is 10 mod 6? Okay, what you do is you take 10 divided by 6 and figure out how many times does it go in evenly and what would be your remainder after. So 6 goes into 10 once with 4 left over. So 10 mod 6 is going to be 4 because that's the remainder. If you want to pause this video and try the last 5 on your own and see what you get, go ahead and pause it. I'm going to go through the answers real quick here. 39 divided by 6 is 6 remainder 3, because 6 goes into 39 in the form of 36 6 times, and then there's 3 left over. So the answer is going to be 3. 39 mod 6 is 3. 12 mod 4, 4 goes into 12 evenly. So it's 3 remainder 0. Your answer is 0 here. 17 mod 2 goes in evenly 8 with a remainder of 1. So your answer is 1. And when we get to the last 2 expressions here with 0, 0 divided by 5 is just 0. So your mod is also 0. Okay. 5 mod 0, you're taking 5 divided by 0. And we just talked about how you can't do that, how that's a no-no. So you'll get an arithmetic exception actually with this because you're trying to divide by 0. Okay. Ooh, I'm almost there. I have 2 slides left. Using the mod operator. Why do we use this? Okay. It'll come up a couple different times throughout this course. The most popular way is deciding if a number is even or odd. So if you're modding by a number by 2, when the remainder is 0, that number is actually even. Okay, so if I say 10 mod 2, 2 goes in evenly to 10, which means that it's an even number. Okay, if you're modding a number by 2 and the remainder is 1, that means it's odd. Okay, so this is just one example of how we use it. It's going to come up a few other times in different programs that we write, and you'll see how we use it more, but it is useful. Okay, it's not just something I'm trying to throw at you to make your life more complicated. It is going to be useful when we run our programs. Okay, last thing. Okay, I promise. Statements are not relationships. Okay, when you look at this code, it does not go back and run again. And this is something I see with beginner programmer students. When you look at this, right, what a lot of students want to do is just kind of do it in their head without tracing through. Remember, codes go from top to bottom. They run in a sequence. Things don't go back and get modified just because future things change. So what I've had students do is look at this and say, okay, I have a bill, I have a tax. Oh, I subtract 10 from the bill, and then I'm going to print off the tax that comes with that bill. And students will say, okay, my bill is 30, but I'm subtracting 10 here, so my bill is actually 20. And then if I take 10% of 20, that means my tax should be 2, right? And so total tax is $2, done. No, don't do that, okay? Don't fall into that mistake. Statements are not relationships here. You got to trace through. So it starts here. Bill is 30. My tax is 3 because I take 0.1 times what the bill currently is. The bill currently is 30. So tax is 3. When I come here and subtract 10, okay, the bill becomes 20, but tax does not change. Okay, statements are not relationship. Just because the bill changed here doesn't mean I go back up and the tax changes. Okay, this code has already ran its course. It's done. I don't go back and change that. Okay, so when I print off the total tax, it prints off what is currently stored in tax, which is $3, 3.0. Okay, so please be careful of that pitfall. Do not just look at a code segment and assume you know what's happening, especially as you're starting off your coding journey. You want to make sure you go top to bottom, trace through. Don't jump back at code. It's not a relationship. Okay. my gosh, did we finally make it? Is it finally time to be done with this video? Thank you guys so much for following along with me. That was a long video, so I appreciate it. If you liked this video, even though it was long for you, please click the like button. Subscribe to my channel for hopefully shorter videos in the future. But I appreciate you sticking around with me for this long. Thank you so much. I will see you in the next video.